Hey everybody, we're going to do a quick tutorial for the simple scatter geometry node setup, which kind of just help people get a feel for it and how it works. Let's go ahead and get started. I'm going to try and keep it quick. We're going to start with the plane, scale it up. We're going to apply the scale to it so we don't have any issues with that later on. I'm going to subdivide some, get a little bit more detail. And this will be kind of our environment that we're going to put this on. As of right now, it's kind of boring, so let's add in some, let's do some clouds. We're going to scale this up quite a bit, maybe not that high. There we go. Maybe just get some fun terrain type going on here. Scale it down a little bit. Perfect. Let's go with this. So what we're going to do is we need to come in and add the geometry nodes tag to that. And if you are starting with a new file, you're going to append it through the simple scatter file that you get from your download source. This download source is going to come through the node trees. You'll append in here and you'll bring in the simple scatter node. That should bring everything in. It's already in this file, so I didn't append it myself. So that kind of brings in our geometry node system there. So to use simple scatter, we need to have some sort of object we want to scatter. I've set up this file to kind of have these trees that you saw kind of on the splash page for it. They're just these two simple little guys, nothing special. Their scale's zeroed out. They're not on center. Not a big deal for this. But with the geometry node set up, our first option we have here is whether we want to see the mesh or not. This just determines whether or not you want to have something that's kind of floating over and you're using it to control placement rather than the actual geometry. For this case, we're actually going to throw it on this geometry and maybe we'll put a texture on here. We'll see. So first we need to tell it what collection we want to scatter. We want to scatter our scatter objects collection. And there we go. Now you can see nothing's kind of come up yet. That's because there's a couple of things I've got a setting on here that's not supposed to be there. But nevertheless, let's keep going. Let's crank up this density a little bit to get a couple more. Maybe make this a little bit bigger, just so we have a little bit more space. Scale that back down. Let's move the instance objects out of the way. So you can kind of see we've got our objects thrown on here, but it's only using this green tree. With geometry nodes, you'll have to come in here and tell it that you want to use multiple objects, because otherwise it's going to look at the collection and say, okay, you want to put this entire object and all of its pieces in the same spot, and you want to multiply it. Whereas if you have a collection of 10 different types of grass and you want it to throw each type of grass, you want to tell it that there's multiple objects. Now right now we kind of got a weird thing going on. Geometry nodes isn't optimized for this. When you have different attributes, it's not sure how you want to interpret that attribute. So we need to click this flag and toggle it and tell it that we want to use, it's a boolean in the geometry nodes. So we want to tell it there's a 1 for true. We want multiple objects, or there are multiple objects in this collection. Okay, so let's keep it that way. We'll come back to some of these, the proxy objects and the proxy collection. I'll come back and cover those. But some of the base functionality here is we have a spread feature. This spread feature tells us how closely the trees can spawn together. If you zero it out, they can spawn on top of each other. You've got these intersections coming or happening. The more we scale that up, let's say maybe 12 inches, maybe we don't mind a little bit of overlap. Let's say we're okay with the 12 inches. And then your density, it'll keep throwing in there as close as it can. But at a certain point, raising that density is not going to do much because you want them to stay 12 inches apart, and eventually you get to a point where it's like, I can't put any more on here. If you lower that spread, you get a whole bunch more. But as long as you maintain a spread or a distance, let's maybe bump that up a little bit more. As long as you maintain this spread, the density will start to be affected by how many it can fit with that requirement of spread. Seed, this changes where it tosses them. You kind of play through this. I use this a lot in landscapes to make sure I kind of get like the profile of what I want. If I've got trees in the background and I want to have a certain, profile, I play with the seed a little bit to get different scatterings. But for now, it doesn't really matter. We're not using that toward an artistic goal right now. Bounding box feature. Right now it is off. If you turn it on, it's going to replace all of those objects with bounding boxes. This is good for like ground objects, or just getting, if you've got something with high detail and you just need to see where it's being put, you don't need to actually see it. This works a lot for trees or heavy polygon objects. We kind of turn on the bounding boxes to make sure that it doesn't tax the computer too hard. Another option that we have to do is we can turn on this hide instances in viewport. Now what this will do is it's going to hide this percentage down here. If we've got 100, that was 10. If we've got 100, it's going to show everything. If we've got 50%, it's going to show half, 10%. This kind of helps us mitigate how much the computer is working while we're working in the viewport. This isn't very heavy, so I'm going to keep it at 100%. Right now, it's using this option of density. The density is just an integer value, and this works with our vertex group, so we can kind of weight paint to put things on here. Otherwise, if you just want to keep it as a 1, 1 means it's going to put the density as 100%. It will put it all over the mesh. If you use 5, it's only going to throw it on half of the vertices or half of the mesh that's out there. So we're just going to keep that at 1 for now until we create our vertex map. For that, we're going to come into our object data properties, and we're going to make a new vertex group. This vertex group we're going to call just tree cover real quick. There we go. So what we're going to do is we're going to weight paint. So I can come in here to weight paint, and you can actually start and paint onto here. So let's say we want a little path that kind of comes through. Let's make it wide. Now it's not actually applying anything, and let's actually do this, change this so you can see that as this paints. This vertex density group, we want to tell it we want a different attribute. Now there's a field, and we can come in and find one of our vertex maps, the tree cover map that we put. Now right now it's only throwing the trees where I've put the vertex group where I'm painting. So let's go ahead and real quick edit. We're going to remove everything, and we're going to tell it we want everything to have a weight of 1. So what that means is now it's trying to throw them all over the weight paint map. See how it's all red now? What we can do is we can come in and we can now tell it we want to paint with a 0 where we don't want the trees to come, or where we don't want the trees to be. So we can say, okay, we're going to have a little path that comes through here. And let's say maybe it splits. We've got 2 different ways. Sometimes it can be tricky because it can look at that and think maybe I can still throw a tree there. So if you don't want it, we need to paint it all the way gone. But that's good enough for our purposes. Maybe get rid of these trees here on the edge we don't like. All right, perfect. So now we have a vertex map, and that is saved in here. You can select it, and you can see which vertices it's affecting. You can tell it whether you want it to affect all or none. Right now we've got it affecting everything. Oh, accidentally hid the, there we go. So now we're telling it that we want to put this on the vertex the vertex group map. That's called tree cover, and that's where we just painted those lines. Another option that we have is we can come in here and we can do an image-based density. Now what that requires us to do is we need to come in and we need to UV unwrap this plane to make sure that it is set up correctly, because it'll be pulling UVs, and we'll need to reset up here under UV map. We need to pick the UV map that this object has. So let's call this, tree distribution. So we're going to use that UV map. So now we can come in here and find the 2D map called tree distribution. And now what we can do is we can tell it, oh, we want to apply them to it. Let's do this just screen dot. It's just a circle for us to kind of see. So now it is using that image, that black and white. You can kind of see the thumbnail here. Black is 0, so it's not going to put anything there. White is 1, so it's going to put all the density in that area surrounding it. Maybe it's scooted in so we can see a little bit more. Add some of the density. You can see how it's using that texture space applied to this image, or to this plane. If I were to add it in here, let's see, base color. Let's change this to image texture, and a screen dot. There you go. You can see that it is trying to apply it where it is white, and it's not putting it where that image is black. So Go ahead and turn that off because we're not going to use that. Change this back to RGB, make it white. Not important. But anyways, that was the image density. Now this is kind of a waterfall system, so if we keep this on, we'll need that to move on to our noise-based density. And again, Geometry Nodes doesn't know what type of attribute you're trying to use here. This is a Boolean because it's got the question mark, so we want to tell it that it's going to be a regular value, a 1 or a 0. So 0 means no noise-based, 1 means yes, we want to use noise-based. Now this is a waterfall system between the vertex group, the image, and the noise. If I turn off this one, it's going to default back to the density. So if we want image-based, we're using an image, we're using a noise image that's being generated when we use this noise-based density. So if we turn on our noise-based density, we have a generic control in here. We can control just how big the noise is. So if we get down, we'll get, or the smaller we get, we're going to get bigger and bigger chunks of noise. And as we get bigger, you can kind of see it narrows down the size. You can go into the Geometry Nodes editor, and in here you can see there's a group here called Edit Noise here. We can tab into that, and here's all of your controls for that noise texture. You can move it around, you can add in detail, roughness. You can do that with the black and white texture map that's generated from that noise. So we're just going to keep it right here for now. It's a simple cover of that. All of this stuff can be found in the PDF. Kind of goes over what I cover in this tutorial as well. Let's keep going. This normals offset. Actually, let's switch off noise-based and image-based. Let's just go back to our vertex group that we painted, the weight paint that we used. We have a normal offset here, which is actually going to take these objects and it's going to move them away from the surface mesh or closer. This can be helpful if you can, as you can see right here, this tree isn't quite underground, so we've got a stump that's sticking off. So what we can do is we can, kind of push it down until we make sure everything is, nothing's floating in the sky. So the normals offset can also be moved away from the mesh. So if you had something that you wanted to float off of the mesh, you can go the opposite direction and move them all up. Aligned normals, as you can tell, for trees, it might not apply, but if you have stuff that wants to be coming directly off of the surface mesh, let's maybe get a shaded view in here so we can see better and maybe turn on our wireframe. You can see this area bends, and so if we had a rock here, the rock would want to obviously sit parallel to the ground, or perpendicular to the ground, so we would want to have this align normals on possibly for that. Trees are not a great example for that because most trees tend to grow straight up, so we're going to turn that align to normals off. Further down here we have starting to get into our rotation controls. We have our X rotation and our randomize X. X rotation is just going to move all of the objects, as you can see. It's an arbitrary number, it's not in degrees. That might be something that I change as we move further along, but for now it's just an arbitrary number. And it controls all of them in the same direction. Now for a forest, that's not very helpful because we want these trees to kind of grow, rotate randomly just a little bit in each direction to kind of give it that natural feel. So when I turn it on, you can tell some go one way, some go the other way. So let's put it at maybe 20. Maybe that gives us enough discrepancy between them to look a little bit more. And let's get rid of this wireframe for now. Gives a little bit more visual interest because now not everything's perfectly lined up. Rotate Y is going to be the same thing. Obviously it's going to go this way. It's going to rotate all of them the same direction. So now maybe if you've got like a wind or something pushing one direction, you want them all to lean that way. But for our purposes for this forest, we want them to kind of be random as well. So let's put them 20. Again, this is just an arbitrary number that kind of pushes things in different directions. And randomize Z is going to have the same thing, but randomize Z is set up to use the instance local Z. So right now, if we rotate, you can kind of see it's kind of a fun little effect with that little bulge on the side of these. As we rotate them, you kind of see they kind of wiggle. It's going to rotate all of them at the same pace. You can see all these edges are moving around at the same speed. We obviously want random because we don't want these trees to look like they're all rotating at the same amount. Let's put it in maybe 30. Then we've got all these trees going every which way, which is good. But the scale, everything, it's not a real, doesn't look like a real forest because everything's the same size. Our base scale control just changes all of them. So maybe we could thin them out if we wanted. We can, for our purpose, we're just going to keep working with what we have here. USR is the uniform scale randomizer. This is another Boolean with a question mark, so we can tell it whether we want this to be true or false. We want it to be true, and right now what that does is it's saying, okay, all these objects can either be a scale of 0.5 across the board or 2 across the board. So that's why we've got some small ones and some big ones. That scale might be a little bit too big, so let's make it 0.5 and 1. There we go. Now we've got some of the smaller trees in here with the bigger trees. Let's change that spread again to keep them from bleeding so much into one another. And let's turn up that density a bit. Maybe that's a little too far apart. There we go. That looks a little bit better. So the USR, Universal Scale Randomizer, lets you, obviously choose how small the smallest one can be. You can change that down to 0.1, have some little itty bitty trees. You can also change it to be, up to size like 2 times what these objects are scaled at. Doesn't quite look very good. Generally, the range that I like to stay in is, 0.5 to, let's say, 1.5, maybe 1.25. Just so we don't get too much bleed and overlap. Another option that you have we can use is the non-uniform scaling. The non-uniform scaling lets us control the ranges for the X, Y, and Z scale. So if we turn this on and turn off the USR, you can kind of see everything's kind of gone a bit wacky. It might be what you want to look for, but let's go over the options. Right now it's not scaling them on the X or the Y. The only thing that's being changed is the Z, and it's scaling between half scale and 1.5 scale. So maybe we'll keep those where we're at, but so you can see what it does. If we want to change the minimum scale, see how these trees are getting scaled down on their individual x-axis? They're getting a little bit skinnier. And that's kind of what we want, because some trees are going to change in shape. We can't go too far, because if you go too far, people are going to look at that tree and say, that's not supposed to look like that. That looks a little weird. So we're going to just stay with the 25% change on that. And we're not going to make them half scale. As you can see, some of these trees look silly if you scale them down that far. So maybe 0.8. We want to keep them maybe 85% of that scale. There we go. And 150 is way too high, so maybe 125. And maybe we want some X as well, but maybe not as much. So we'll scale to 1 point, just up to 1, how about? Let's change that to 1.15. So now we have kind of, with our 2 tree assets, we've created an entire forest that doesn't look like it's repeating or tiling. It's generated completely based off what you painted. That's kind of the purpose of this simple scatter, is to let you kind of look like you have an environment that's much bigger than it actually is. So the last option that we just added is this proxy collection. This proxy collection lets you replace these. If you've got heavy geometry but you kind of want to see where it is so you can line stuff up where you want it, we can come in and turn on our proxies. And to do that, before we do that, I'm just going to set it up here for you. We created a collection here that has proxy objects in it. For this scene, we just created 2 cones to kind of be the same. They've got their origins roughly the same height. If you look, this is just something to help us visualize what these are going to look like. And they are in a separate collection called the scatter object proxies. Now let's turn on proxy objects, tell it we want proxies. Obviously they all disappear because this collection is not referencing anything. But once we change that collection to our scatter object proxies, it starts to replace them in the correct area. And you can see, not multiple objects, proxies. You can see where all the yellow trees are, it's replaced with a yellow cone, just to kind of simplify what we're doing. The only rule about this is we need to make sure that things are in the right order. If I were to rename this to tree just we need to get it ahead of, let's change this to tree 2 or tree 1B. There we go. So now this one is tree 1, which would line up with the first object in our scatter objects. If we reset, the computer's going to think that it wants. If we see where, or we look where the yellow trees currently are and we turn it on, it's now going to put the green tree there because it is second in the proxy hierarchy and it's not lining up with where these first ones should be. So the tree 1 that we want the green proxy for is tree 1, so let's name this one back to tree 1 proxy. And this one here we're going to change back to tree 2 proxy. And it doesn't quite update, you have to kind of toggle it and give it a kick in the pants to get going. But then the proxies are distributed in the correct order. We can do this for as many proxies as we want, we just have to make sure that order is the same. Now we can hide those collections, and our scene stays as it is. You can go in and render even if you have the proxies out, and you come in and do, let's add a camera real quick. We're just gonna lock the camera to the view. There we go. Even if we come in and render, I have no light. Let's turn on the sun real quick. Come in and render. You can see it does render with the actual objects. It's not going to render with those proxy objects in there. It's just for the viewport to help you kind of establish a better visual hierarchy and to not bog down your system. So that's Simple Scatter. I think we've covered all the basics. If you have any questions, feel free to write into the email that's listed on the splash page. I'm happy to answer any questions that you have or address any problems that you might have. Otherwise, I hope this helps you create the environments you're looking for, and I hope that you enjoy it. Thanks for stopping by.